The Himalayas, Northern Mountains. Approach this topic with structure in mind. If your structure is clear, revision becomes effortless. We will move step by step: formation, divisions, regional logic, and significance, and build one coherent picture. Keep the map in your head as we move forward. Now, let's begin with formation. Before 50 million years ago, there was the Tethys Sea between Gondwana land, including India, and Angara land, or Eurasia. Sediments accumulated in this sea. Due to plate drift, the Indian plate moved northwards. Then came compression. After collision, the Indian plate pushed beneath the Eurasian plate. Thrust faults and folds developed. Seabed sediments were uplifted. This is why the Himalayas are young fold mountains, formed by the collision of the Indian and Eurasian plates. Exam trap here. Students memorize young fold mountains but forget the mechanism. Examiners expect process clarity. Sediment to compression to folding to uplift. So you must understand the sequence. Now that you know how they were formed, let's understand the timeline. Around 71 million years ago, India detached from Gondwana land. By 55 million years ago, it crossed the equator. From around 10 million years ago to the present, collision and uplift continued. And here is the important line. India is still moving north. The Himalayas are rising at roughly 5 millimeters per year. Why does this matter? Because this explains earthquakes, landslides, instability. Toppers don't treat this as trivia. They connect it to seismicity, disaster management, and even GS Paper 3. That's integrated thinking. Now you understand formation. Let's understand classification. The Himalayas can be divided in two ways. First, longitudinal division, north to south, based on elevation and age. These are Trans-Himalayas, Greater Himalayas, Middle Himalayas, and Shivalik. Second, regional division, west to east, based on river boundaries. These are Punjab, Kumaon, Nepal, and Assam Himalayas. Remember this rule. North-south equals structural. West-east equals river-based. Clear separation saves marks. Now moving north to south, we begin with the Trans-Himalayas. Major ranges: Karakoram, Ladakh, Zaskar. From north to south, Karakoram to Ladakh to Zaskar. Important peaks: K2 at 8,611 meters and Kamet. Memory hack: KLZ order. Many students place Everest in Karakoram. That is wrong. Everest belongs to the Greater Himalayas. Toppers mentally visualize a map while studying. Always visualize north to south layering. Now that you know the Trans Belt, move slightly south to the Greater Himalayas, also called Himadri. Average height around 6,100 meters. Major peaks: Nanga Parbat, Kanchenjunga, Mount Everest. Rock core: granite, gneiss, schist. This is the highest, most continuous range. Now move further south. Middle Himalayas, also called Lesser Himalayas, include hill stations like Shimla and Nainital. Further south lie the Shivaliks, the youngest and most fragile. Between Lesser and Shivalik, longitudinal valleys called duns are formed. Example, Dehradun. Formation of duns. Rivers blocked by rising Shivaliks, temporary lakes, later drained, sediments left behind. Students remember dun but forget the formation process. UPSC often asks process-based geography. Don't memorize landforms. Understand how they formed. Now zoom into Kashmir Valley. Between Pir Panjal and Zaskar Range, we find Karevas. Karevas are fluvio-glacial deposits. This is why saffron grows here. Prelims loves such microfeatures. Toppers highlight rare terms like fluvio-glacial deposits. because one correct microterm can eliminate three options. Now understand the shape of the Himalayas. They form an arc. Western syntactial bend, Nanga Parbat. Eastern syntactial bend, Namcha Barwa. Memory trick? Nanga Parbat is closer to Pakistan side, west. Namcha Barwa is in Arunachal side, east. Visual memory beats rote memory. Now beyond the eastern bend, the Himalayas turn southward into Purvanchal. Ranges include Patkai Boom, Naga Hills, Manipur Hills, and Mizo or Lushai Hills. This region lies near the Brahmaputra River and extends toward Myanmar. For understanding this, you should mark directional turns. West arc, eastern bend, southward turn. Spatial clarity wins geography. Now switch to west to east regional division. River boundaries: Indus Satluj, Kali Tista, Brahmaputra. Using these rivers, regions become Punjab, Kumaon, Nepal, Assam, Himalayas. Memory code ISKTB. Students know names but cannot place them west to east. Always revise geography in sequence, not isolated chunks. Now compare them. The Himalayas are wider in the west and higher in the east. Punjab, deep gorges and snow. Kumaon, source of Ganga and Yamuna. Nepal, tallest peaks including Everest. Assam, rapid rise and north-south oriented ranges. Mains angle. If asked to compare western and eastern Himalayas, this slide gives structure. Now, why do the Himalayas matter? Climate control, blocking cold winds. Defense, physical barrier. Water tower, perennial rivers from glacial melt. Students write emotional answers in mains. Examiners expect cause-effect logic. Block winds to protect climate. Glaciers to perennial rivers. Barrier to strategic security. Structured thinking scores. Now connect geography to economy. Energy generation. Agriculture, including tea. Forest wealth. GS linkage here is strong. Economy, ecology, resources. Toppers think cross paper. They don't confine geography to paper 1. Now consolidate. Formation. Indian and Eurasian plate collision, Tethys Sea. Longitudinal order north to south. Karakoram, Ladakh, Zaskar, Greater, Middle, Shivalik. River code west to east. Indus, Satluj, Kali, Tista, Brahmaputra. Anchors. Nanga Parbat west, Namcha Barwa east. Key peaks. K2 in Trans, Everest in Greater, Kamet in Zaskar. If you can reproduce this structure without hesitation, you are exam ready for this topic.